Hello, my name's Phil Beecham. I'm a chemistry professor with 40 years at Cal Poly Pomona. I'm also a member of the Citizens Climate Lobby with a goal to place a fee dividend on fossil fuels that represents their true cost to society. The UN recently issued its 6th report on climate change. Thousands of pages, thousands of references, hundreds of scientists. There are actually 3 working groups. I'm looking at a 42-page summary of the Working Group 1, which is physical science basis of climate change. I'll cover just a few examples from that report. The report is mostly data and projections. It establishes a baseline of 1850 to 1900, that's 50 years, a reference period for comparison of temperature and carbon dioxide levels with the current values and future projections. The first 3 pages are mostly narrative, and I've just picked out a few highlights from those 3 pages. The top 3 greenhouse gases are carbon dioxide, methane, and nitrous oxide. The last 4 decades are the warmest in the reference period, and each decade has gotten progressively warmer. Global precipitation has been increasing faster since 1980. Typhoons and hurricanes are shifting towards the poles in both hemispheres. Human influence is causing retreat of world glaciers, snow cover, and Arctic sea ice, which is threatening the water supply for many nations around the world. Sea level has risen 8 inches since 1901, and the rate is accelerating, heading towards 1.5 to 3 feet higher by 2100. Oceans are about 30% more acidic than previous millions of years, heading towards 50 to 200% more acidic by 2100. This particular slide looks at global surface temperatures from 1850 to 2020. So the black line is actually the observed temperature for the past 170 years. You can see it's pretty flat. Starts to head up around 1950, 1960, up to this point right here. If we continued the projection of that line to 2100, we would be at 3 degrees or higher of Celsius by 2100. The gold line is the simulated human and natural influences, and you'll see it follows very closely to the black line. The computer models are pretty accurate. The green line is the simulated natural influence only without human influences. And you can see that stays pretty flat, leading to this difference in temperature of 1.1 degrees Celsius over the recent historical past. It was hoped that by 2100 we would not go over 1.5 degrees Celsius. That was the 2015 Paris goals. This is pretty much dead in the water. The new hope is that we don't go over 2.0 degrees Celsius by 2100. So that's our new target, but that also is appearing to be a long shot. This is the 1.1 degrees Celsius that we've observed. This is the temperature change from 1850 to 1900. And if you look over here, it's a little bit disturbing because the actual greenhouse gases that we mentioned are showing an increase of 1.5 degrees Celsius. The reason we don't see this full temperature increase is because when we burn coal, there's sulfur in the coal. And the sulfur oxidizes the sulfur dioxide. And sulfur dioxide in the air scatters the light, and that cools the temperature. So even though we have this much heating capacity in the atmosphere, part of it is taken away. Now the problem with this is that it goes away pretty quickly because this turns into sulfuric acid and washes out of the atmosphere in just a few years. You might think this is a good way to cool the temperature, but in fact, sulfuric acid is coming out, which is very dangerous, so we can't really use this strategy. The report gave 5 different scenarios, and so those are shown here. The scenarios all use gigatons, which is a billion, 10 to the 9th. Ton is the metric ton, 2200. So this is the reference unit. We are currently putting in 40 gigatons of carbon dioxide per year. So that puts us right about here. This is carbon dioxide added per year. And if we come down here, this is about 2020. And so we have 2 scenarios that are completely unrealistic. The first scenario is hopelessly optimistic and assumes that we'll hit 0 carbon dioxide in the atmosphere by 2060. The second one is also pretty hopeless. It says we'll hit 0 by 2080. So we would have to already be working to do this. The top scenario, the 5th one, is also pretty unrealistic because it assumes that we're going to hit 130 gigatons per year by 2100. The only way this could happen is if we hit some kind of a tipping point that would destabilize everything and put out an enormous amount of methane and carbon dioxide. So it's very scary, but not real optimistic. The two plausible ones are shown here. The third one here is pretty optimistic. It assumes we're getting control of things and we're going to level off. It's going to flatten out by 2050, and then we're going to start down in terms of the amount of carbon dioxide put into the atmosphere. So this is 10 gigatons. So this is pretty much a long shot. You got to remember that as we move towards this direction, we're going to have billions more people on Earth. And so then we're saying we're still going to cut down the carbon dioxide, which seems, like I said, a pretty long shot. This line right here is business as usual, shows the carbon dioxide going up, and up. By the time we get to 2100, we're putting in 80 gigatons of carbon dioxide per year. This is not good, but that's the way we're headed right now because we haven't really changed much. Just to point out something to you, the heat from burning all the fossil fuels is one-time energy. Once you burn it, that's done. But the carbon dioxide that comes off from burning that fossil fuel stays in the atmosphere for hundreds of years to thousands of years, and that energy lasts for centuries. So every year we're going to keep putting out that energy year after year for all the carbon dioxide that's in the atmosphere. This is the problem. This chart here, and they have many charts that show this, intensity of 10 years or 50-year extreme events. This one right here is for hot temperature, but they have precipitation, droughts, and so forth. So what we're seeing over here is in this 50-year period, there's 5 10-year periods. And they're looking at a 10-year period, the hottest event in that 10-year period. And then they're going to look at what happens if we increase the temperature 1 degree. That's where we are right now. So that's going to happen 3 times in that 10-year period as the hottest event here. If we go up to 1.5, it'll happen 4 times. If we go up to 2.0, it'll be 6 times. If we go up to 4 degrees, which would be a total disaster, it would happen just about every year, 9.4 times. The 50-year extreme events, again, once now in 50 years, that would be this event, so very extreme. If we go up to 1 degree where we are now, that's going to happen 5 times. That's what we're doing now. If we go up to 1.5, that will happen 9 times. If we go up to 2.0, that'll happen 14 times in 50 years. If we go up to 4 degrees, it'll be almost a yearly event, 39 times. So we really have to stay away from this. Historical carbon dioxide emissions over the whole 170-year period have been about 2,400 gigatons. That's billion tons. About half of that stays in the atmosphere, and half of that goes into the oceans, the plants, and the land. If we look at the remaining carbon budget from now till the end of the century, we can see how much carbon dioxide we could add to avoid the goals that we want to stay under. Right now we're adding about 40 gigatons per year. If we do nothing in the next 30 years and we stay at 40, that'll be 30 times 40. That will be 1,200 extra gigatons we will have added into the atmosphere where we actually want it to be 0. And if we go all the way to 2100, that will be 80 times 40, 80 years times 40 gigatons per year. That will be 3,200 gigatons of carbon dioxide where we want it to be 0. So they have an extensive chart. I just picked 2 situations. Okay, one situation we want to stay under 1.5 degrees, that's the Paris Accord, and the other one is we want to stay under 2 degrees. So these are the goals for 2100, that's 79 years away. We're currently at 1.1. So the remaining temperature, we have 0.4 degrees here, that's less heat, and if we add 300 gigatons of carbon dioxide, we will have about an 83% chance of succeeding in that goal. Well, 300 divided by 40, that's 8 more years. That means we're going to pass this mark by 2029. Pretty much a hopeless cause here. We're not going to make that. If we allow ourselves to go up to 2 degrees, which of course has more dire consequences, that's 0.9 degrees of heat, we can add 900 gigatons of carbon dioxide. At our 40 gigaton per year rate, that's 22 more years. 22 years would take us to 2043. So again, we wouldn't make it. So we actually have to lower the carbon dioxide down dramatically to 0 by 2050. I'd like to finish with a climate change scientist who's very positive, has hope, Dr. Catherine Hayhoe, Director of Climate Science at Texas Tech. She also serves on the advisory board of Citizens Climate Lobby, which we're talking about here today. Her efforts to reach out and engage people on the importance of climate change has led to her being named one of Time's 100 most influential people. And she has many additional awards. She understands the need for action, but she also offers a positive message for a more hopeful future. Just a little quote here. A thermometer is not liberal or conservative. This affects us all. She has an excellent TED Talk explaining her hopeful climate change message. All you have to do is type in her name. She also has a book coming out at Amazon in September, so later this month, Saving Us, A Climate Scientist's Case for Hope and Healing in a Divided World. That's pretty much the end of my brief presentation, and thank you for listening.